In 1685, as Newton was working on the expansion to the short paper he had sent Edmund Halley that would grow into the Principia, times, as they say, were a-changin'. After a reign of 25 years, Charles II of the House of Stuart, King of England and Scotland, died on February 6th. While Charles' reign had been something of a mixed bag, he had overseen the stabilization of the country after the years of the Protectorate and had worked to rebuild London after the fire. While Charles had Catholic sympathies, there was one thing he understood, especially after his attempt to promote a Religious Tolerance Act in 1672 was blocked by Parliament. England was a Protestant country, through and through. The idea of being free from both papal and continental attachments was stitched deeply into the English identity dating back to the days of Queen Elizabeth. The new monarch, Charles' brother James, was not as understanding of this idea. Looking across the channel to his relative, King Louis XIV, and his absolute monarchy, the newly crowned James II was of a mind to re-establish Catholicism in England and assert the ideas of that absolute monarchy. In this goal, he worked through the institutions of England, most notably the army and the judiciary, to entrench Catholic supporters into positions of power. While these actions were viewed with alarm by many, there was the solace that without a male heir, James' changes would be temporary, as his daughter, Mary, was married to the Protestant William of Orange, and could be seen as someone who would protect Britain's Protestant heritage. In the year 1687, James turned his attention to the academic institutions of the nation, occupied to date only by those who took vows in the Anglican Church. He began with Oxford and London, where he forced the faculty there to accept Catholic leadership of 3 of the colleges of the university. As Newton's revolutionary book was rolling off the presses, James was attempting a revolution of his own, this from his position of power to return England to being a Catholic nation. He promoted a new Religious Toleration Act that would allow Catholics into all positions in the government and the universities. As copies of the Principia began to appear in the hands of mathematicians and natural philosophers, James continued to press his agenda until, in 1688, he overplayed his hand. With the birth of a male heir, the arrest of several prominent members of the Anglican clergy, and the requirement of a loyalty oath by his subjects, James pushed together enough Protestant nobles to form a significant bloc of opposition. This group entered into negotiations with William of Orange to land an army to depose the king. On June 30th, the offer was officially made, and in November of that year, William's forces would land with an armada of 600 ships, invited rather than invading, and captured James and Kent in early December. Not wishing to engage in regicide, William allowed James to escape into exile at the French court. Now lacking an official monarch, and with a foreign army standing on its shores, the Parliament convened to consider its next steps. William, however, had understood the arrangement that he had entered into. He would be king, but it would not be a position like that of the Bourbons in France and Spain. Instead, it would be something constitutional, similar to his position as stadtholder in the Netherlands. When the Parliament came together in 1689, the House of Commons, elected by the various stakeholders across the land, it took up the business of crafting a new monarchy, one limited in scope and power, with an even greater role for the representatives of the people. Among their number was a minister of Parliament, whose anti-Catholic and limited monarchy writings had made him the darling of his fellows. Isaac Newton, so long the avoider of conflict and the spotlight, was about to step on a much more public stage than he had ever known before.
Hello, and welcome to the Scientific Odyssey. The Scientific Odyssey is a many-part journey into the history and philosophy of science. My name is Chad Davies, and I'm the writer, host, and producer of the podcast, where we consider the ideas, processes, and results of over 2,500 years of scientific inquiry, and discovery.
Series 3, Finding Our Place. Episode 27.5, Supplemental. Isaac Newton, a Public Man. With the publication of the Principia, Isaac Newton was no longer an unknown academic toiling away in relative obscurity at a smallish English university. For the first time, his name found its way to the tongues of those beyond the limited world of mathematics and the secretive meetings of the alchemists of London. While it was scarcely understood at first, the work was praised by natural philosophers across England and on the continent as being something both monumental and groundbreaking. The author was now 45 years old, slender, with long gray hair, and a reputation for eccentricity among his colleagues at Cambridge. As Halley began to promote the book whose printing he had financed, hoping to at least make back his investment, copies were sent to anyone of influence that might be able to sort of speak to its greatness, even if they didn't exactly understand what was so great about it. The new king, James II, who had succeeded his brother just 2 years earlier, was one such recipient. The book was accompanied by a note that read, quote, "If ever book was so worthy of a prince, this, wherein so many and so great discoveries concerning the constitution of the visible world are made out, and put past dispute, must needs be grateful to your majesty." End quote. Halley then went on to write, quote, "The sole principle is no other than that of gravity, whereby in the earth all bodies have a tendency towards its center." End quote. For his part, James, who had served as the Lord High Admiral before ascending to the throne, had had an interest in the explanation of tides, a topic Halley cleverly summarized from Newton's more lengthy explanation. But of course, by this time, James was up to his eyeballs in the turmoil created by his efforts to move England back to Catholicism. He would only last 1 more year before fleeing England forever to avoid the fate of his beheaded father. Newton himself was embroiled in the controversy in much the same way as his colleagues at Oxford has been, through the attempt by James to appoint a Catholic to a position at the very Protestant Cambridge. The Benedictine monk, Alban Francis, was to be exempted from the various examinations of faith, just as had been done a decade earlier for Newton. But in this instance, his confession of the Catholic creed was an explicit violation of the don't ask, don't tell policy that had been put in place by Charles II. The faculty of the university fought the appointment, and Newton was right there alongside them, marshaling his intellectual resources and his deeply held contempt for all things popish, something inherited from youth during Cromwell's Puritan protectorate. In 1687, as the Principia was being printed, he, along with 7 of his peers, went before an ecclesiastical commission headed by the notorious Judge Jeffreys. Now, Jeffreys actually had been a former classmate of Newton's, but now had a reputation as something of a hanging judge, having sentenced to death hundreds of supporters of a nobleman who had attempted a failed rebellion after Charles II had died. The protest turned into something of a disaster. Led by the inept and personally troubled vice-chancellor of the university, the group's arguments were brushed aside by the judge, who favored James's policies. Shackled by poor leadership, the group was unable to mount an effective defense until the vice-chancellor was convicted of disobedience, dismissed from his position, and stripped of his titles. Freed now, the 7 asked for additional time to respond to the proceedings. While they were chastised, Jeffreys gave them some extra time to prepare for their defense. 3 weeks later, they would be called back before the judge and reprimanded, being told in essence to stick to their academic work lest something worse happen to them. Nevertheless, even though Francis's enrollment was forced through, the faculty of the university did prevail in preventing the monk from becoming appointed as a Master of Arts, because, basically, James wouldn't stay on the throne long enough to see his will put into action in this matter, and his supporters soon found themselves out of power. In retrospect, it was a surprising and risky thing for Newton to have done, getting involved in this particular fight. The man who had hidden in the shadows at Cambridge, and that possessed secrets that would have ruined him had they become known, had stuck his neck out for his college and its shared culture, which, by the way, was a profoundly conservative culture that he strongly identified with. Thus, moved by his unbending principles, he had determined that on this matter, standing up was both the right thing to do and something that would improve his place among his fellows, all of whom were Protestants to a man. As part of the 8-man commission, he published 2 essays speaking to limitations of the king's prerogative and power, something that marked him out as a conservative Whig in the party politics just beginning in England at the time. It also allied him with those who felt that it was time to limit the power of the monarchy. Because of this, when, at the end of 1688, the Glorious Revolution took place, and the Dutch fleet sailed to England to deliver William and Mary, both grandchildren of Charles I and devout Protestants, to the shores of England, Newton was elected by the University Senate to a position as Minister of Parliament to represent them. As a member of this body, he would add his vote to those declaring that James had abdicated his throne by leaving the country. Soon, the Parliament would not only install the members of the House of Orange as their monarchs, but would work with them to create the grounds for a monarchy established not by divine right, but through constitutional authority. To this was added a declaration of rights and an injunction against the standing army as a means of tyranny. However, while religious toleration was included in this declaration, it was not extended to Catholics or, importantly for Newton, anti-Trinitarians. Also, at about this same time, Newton suffered an additional setback when his attempt to be named the provost at King's College was declined, despite the strong support of the new monarch. One thing that should be noted here is that while there is little record that Newton spoke during the debates of the House of Commons, it seems likely that his behind-the-scenes influence would have been greater. He dined with the new King William III and likely met with others to help craft the arguments and documents that would formalize the basis for government. A basis for government, by the way, that would be taken very seriously by those English subjects making a life an ocean away. However, even as things were discouraging on the academic front, new opportunities were appearing in a completely new arena. While serving in the Convention Parliament, as it was called, Newton rented a room near the House of Commons and sometimes attended its sessions in his academic regalia. As the days grew into weeks, the allure of the city began to present itself to him. He dined out with other MPs and members of the intellectual and political elite of London. On one occasion, he had a self-portrait made by the best portrait artist in the city. In the evenings, he attended meetings of the Royal Society and met with men such as Christian Huygens, who now lived in London, and that diarist of the plague years, Samuel Pepys, with whom he struck up a friendship. He soon found that he enjoyed the intellectual and urbane environment of London, especially as his newfound celebrity freed him from having to live in the shadow of Robert Hooke. Among those who came into his circle was an older colleague and a pair of young men. The colleague, John Locke, would be among those who would attempt to extend Newton's ideas of universal laws beyond the realm of the physical universe to the structures that govern the affairs of human beings. Locke's great work, an essay concerning human understandings, would be profoundly influenced by the ideas he found in Newton's Principia, and he would become an advocate of Newton's for the remainder of his life. Locke was probably the one man whom Newton might have viewed as a true friend at this time. Not only was the political philosopher as close to an intellectual equal as Newton might find, he was a man of more experience and insight, having spent several years in exile in Holland before returning with the House of Orange during the Glorious Revolution. While men like Halley would have been highly regarded scientific colleagues, Locke and Newton shared a greater number of interests, including, it turned out, both politics and religion. Locke can be seen as the founder of liberalism in England on the basis of empiricism, and it is clear that the two men would have found themselves staunchly in the Whig camp of the time. Moreover, both men opposed Hobbes' materialistic view of the world and its governance. Locke instead promoted a view of governance that put forth the idea that the government was at the service of the governed, an idea that would become central to Newton's political philosophy when he took his position at the Royal Mint in 1696. Finally, in a series of letters between the two men, we find Newton opening up ever so slightly, or maybe even a little more than ever so slightly, about his anti-Trinitarianism, a view Locke seems to have at least been sympathetic to. In this, he was careful to couch his words such that if the letters were intercepted, the conversation would seem like an intellectual discourse about textual interpretation. During this time, he was also engaged by Pepys in a discussion of probability to aid the writer in his habitual practice of frequenting the gambling tables of London's clubs. Newton worked out the best sort of bets to be placed given various odds, working out the average winnings Pepys could expect if he were willing to wager large sums over statistically large numbers of events of chance. So meticulous was Newton in this that he gave Pepys an account of what he could expect to win or lose down to the very last penny. Now, the two younger men were a very different sort of thing. One was a British mathematician by the name of David Gregory, and the other a brilliant Swiss polymath by the name of Nicolas Fatio de Duillier, or Fatio as he's most commonly known. As we'll have much to say about him in a few minutes, let's take a moment to focus on Gregory. As word of the Principia began to spread, largely due to the efforts of Halley at first, there arose a bit of a divergence of opinion about its veracity. While men like Huygens were concerned about the occult nature of the attractive force of gravitation, there was something more going on. There was something of a whisper campaign, suggesting that the book wasn't really all that in a bag of Cool Ranch chips, if you sort of take my meaning. Not surprisingly, these sentiments likely originated with Hooke in various coffeehouse discussions and dinner parties. It is thought by many historians that he even went so far as to author a somewhat passive-aggressive review of the book anonymously, wherein he praised certain parts of it while also playing up all of its shortcomings, real or perceived. As a counterweight to this, a number of others came to Newton's defense, among them Gregory. Professor of mathematics at the University of Edinburgh, he, along with Halley, was one of the few men in England who could understand both the mathematical underpinnings of the theory of mechanics as well as its applications. As such, he was a crucial figure for moving the book out of the realm of the barely understandable into something much more accessible. As a result of this, he became the leader of a circle of other young mathematicians who clustered around Newton and advanced his work, including one Abraham de Moivre, who it is said was so obsessed with the Principia that he tore pages from his copy of the book so that he could read it while traveling between tutoring appointments with various students. For their service, Newton shared a good bit of his mathematical work with this group, written over the years at Cambridge, a gift of patronage that launched many a career. For Gregory, that gift extended to Newton using his influence to have him appointed Savilian Professor of Geometry at Oxford when Edmund Halley's candidacy fell through on suspicions that Halley harbored potentially unorthodox religious views. An irony quite rich, by the way, given both Newton's own heresy and Gregory's very loosely held Presbyterian leanings. What can be seen from all of this was that Newton was finding a place, if only temporarily, in London. England's one true metropolis had flourished in the 25 years since the Plague and Fire. The urban planning undertaken by Hooke, Wren, and the commissions upon which they had served had begun to be realized in a city filled with brick buildings, wide straight streets, and new churches, most notably Wren's masterpiece, the new St. Paul's Cathedral. It was a trading hub to rival the other European capitals, and was rapidly becoming a center of baking and publishing. In all of this, many of those with connections to the crown were working to find Newton a place in the government, one that would bring him to the city permanently. For a man as tightly wound as Newton, the ever-increasing pressure and tension created by his conflicting desires began to take its toll. So, the other man we need to spend a bit of time discussing is the Swiss mathematician and mystic Fatio de Duillier, as his relationship with Newton has been the subject of a great deal of speculation. Fatio was a flamboyant man, given over to extravagant gestures and stylish clothing. He had gained the favor of William of Orange when he warned him of an abduction plot, and rather than take the proffered reward of a professorship in the Netherlands, he asked to accompany the nobleman to England, where he was quickly appointed a Fellow of the Royal Society. Originally a proponent of Descartes' mechanical philosophy, he seems to have undergone something of a conversion event, and became a vocal advocate of Newtonianism, as it was beginning to be called. Hearing that Huygens was still dubious due to the mysterious nature of the gravitational force, Fatio took it upon himself to act as a go-between from Newton to Huygens, especially after Huygens immigrated to Britain in 1690. This soon grew into a role of compiling the errata, or list of corrections, to the first edition of Newton's work, something that was inevitable for anything that had been published that was that size. This led to a closer relationship between the two men, and it seems that Newton came to have a sincere affection for the brash and somewhat brilliant Fatio. For his part, Fatio nearly worshipped the older Newton and began to lodge with him both in London and on visits to Cambridge. It is here that we should probably take a moment to examine the question of just how deep that relationship went. Over the last several years, there have been a number of historians and biographers who have questioned just what Newton's sexual orientation was. The first case to be considered is always that of Newton's roommate-ship, relationship, whatever you want to call it, with John Wickens, his Cambridge roommate for 20 years in the years from 1663 to 1683. The relationship seems to have been fairly close, with Wickens helping Newton on many of his researches, but it came to an abrupt end when Wickens left the university to take up a position as a country vicar. Now, some have seen this as evidence of sort of a bad breakup between two intimates, but most historians that I've read feel that there's really scant evidence for that kind of position. For my part, the parting of ways probably had a lot more to do with Newton's and Wickens' vastly diverging views on religious matters, something surely thrown into stark light when Wickens was offered his position. I can kind of imagine the argument the two might have gotten into when Newton realized that his closest friend of 20 years was thinking about leaving him to promote what would have been, at least in Newton's mind, a pack of lies the Nicaeans had perpetrated on the faithful for some 1,300 years. Wickens, for his part, would likely have been horrified by his roommate's views, but also would have understood that if he revealed them, it would have cost Newton everything, and possibly even call his own orthodoxy into question. I think that the consensus of historians is that the relationship between the two men, dedicated to the celibate oath of the university as they were, was strictly platonic, and that's probably the best interpretation. The case for Fatio, however, is a good bit more complex. Was it, as many have assumed, merely a case of bromance, as it were, taken to an extreme degree, or was there something more? Michael White, in his biography of Newton, goes so far as to say that the two men may well have engaged in a homosexual relationship, but the bulk of scholarship seems to be against this position. As we said, Newton took his vows of celibacy very seriously, but this does not mean there wasn't some form of intimacy and attraction between the two men. What is more likely the case is that Newton, so long cloistered away from the bright lights and fast pace of urban life, such as it was in London, found himself swept away by all of it. The whirlwind relationship with Fatio, likely containing within it a whole range of new emotions and experiences, can be seen as a part of this new reality in which Newton found himself immersed. That Fatio was likely bisexual and thus comfortable with this idea of a romantic relationship with Newton would have allowed for an intimacy that, though it may not have been expressed physically, certainly seems to have been evidenced in the letters the two men exchanged. This new range of emotions, something Newton was likely wholly unfamiliar with, would have added to the tug-of-war that was his new life. What can be said, I think, is that Newton seems to have been both attracted and repulsed by it. He longed for the quiet anonymities of his chambers back at Cambridge, while also enjoying his new role as a man of the public. He hated this fractious nature of politics while enjoying the access he had to the seats of power and influence. He relished the attention of young admirers, but longed for the peace and quiet to get work done. Fatio, in a single person, represented all of these tensions, but, as we will see, he was not the measured and experienced soul that Locke was. Nor was he one to rest in any one place, and his sudden departure from Newton's life may well have precipitated a crisis the older man nearly did not recover from. Almost as soon as it was published, Newton began to work on revisions to the first edition of the Principia, something we said that Fatio, in a sense, helped with. Understanding that it had been a work created in a rush, he knew that there would be value in planning a fairly thorough revision of some of the less mathematically formal parts that had been pulled together in a somewhat haphazard way. Any number of people vied for the position of editor, as the association with the project would make a man's reputation among the scientific community. Among those considered for the job was David Gregory, as was Edmund Halley, again thought to be brought alongside this. The project, however, could not be completed quickly, as Newton would write and rewrite and revise portions over and over again in an order to attempt to bring it more in line with the overriding belief that he had that all things were an expression of God's design for the creation, and that all of his work that he was doing, and I should say that Newton was doing, was nothing more than a rediscovery of knowledge once held by ancient thinkers. For the 25 years after the publication of the first edition, Newton would scour historical texts for evidence that the great figures of classical Greek and Mesopotamian civilization had already discovered his calculus, his laws of motion, and his universal law of gravitation. For Newton, the idea of progress was completely discarded, even as the societies he moved around in embraced the idea more and more fully. When the work was finally moved to the front burner prior to the second edition's printing in 1712, it would be Richard Bentley who would be given Halley's role. It would also be a young mathematician by the name of Roger Coates, a colleague of Newton's at Cambridge, who would spur the much older man to make really significant revisions to the first edition that would redeem it from indecipherability. While Coates would work on this project for 4 years between 1709 and 1712, much as Halley had done with the first edition, he would not share in the other man's good fortune of a long life. Coates, unfortunately, would die just a few years later, his mathematical promise mostly unfulfilled. Discovered in his notes was a statement of one of the most important mathematical expressions in the field known as analysis, something we call today Euler's identity and, with it, Euler's formula. Coates was truly a brilliant mathematician, and it is a tragedy that his work did not continue. In addition to the work on the Principia, Newton also had plans for other publications. In 1691, he began to pull together his efforts on calculus in a work titled De Quadratura Curvarum. The purpose of this was to establish his priority in the invention of a new branch of mathematics over a rival claimant, Gottfried Leibniz, who had published just a couple of years earlier. Newton had corresponded with Leibniz on and off during the 1670s, and the two had shared some ideas on the mathematics of continuous change. We will return to this topic at the end of the episode, as it will become a source of contention down the road a bit. On top of this, Newton began planning a 4-volume work on optics that would extend his idea of long-range action at a distance forces like gravity and magnetism to very small-scale attractive forces. As might be expected, lacking a coherent atomic theory, Newton was unable to make much progress on this idea beyond some hypothetical sorts of things. While he had a strong suspicion that the forces that governed the interactions of Boyle's hypothetical atoms were very much like his gravitational force, he could not demonstrate this either by physical observation or mathematical proof. As such, these ideas wouldn't make it into the earlier versions of these writings. All of this work was interrupted, though, when Newton underwent some sort of a psychological event, or breakdown as it is often called in the literature. I don't want to play armchair psychologist here, and so I don't want to be too specific in my terminology, But sometime in mid-1693, rumors began to circulate around London and in Cambridge that Newton was displaying profoundly erratic behavior and struggling in his interaction with others on even the most basic of levels. Some claimed that he was on his deathbed or had taken leave of his senses entirely, completely. And so the question comes up, what actually happened? In late 1692, Fatio had asked Newton to invest in a project he had interest in that involved the making and distribution of an alchemical potion that had been developed by one of the younger man's other friends. Over the winter, Newton made a number of trips between Cambridge and London to discuss the project, as well as a number of other things. However, as the discussions progressed, Fatio began to pull away from Newton, possibly as a result of the older man's questions about the makeup of the potion and the specifics of how it was being produced, something he would have been very interested in as a practicing alchemist himself. This withdrawal by Fatio seems to have upset Newton's fragile equilibrium, and by July he was no longer in a good place emotionally. The rumors of the state were confirmed first by a letter to Pepys received in September 1693, and then another received by Locke. Both letters were the products of an unhinged mind that may have been struggling with feelings of paranoia and severe depression while experiencing hallucinations of some type. What is clear from these letters is that Newton is imagining various accusations and slights and responding to these with threats of complete withdrawal and even suicide. So why did the breakdown take place? There have been any number of hypotheses put forward, from mercury poisoning to overwork to repressed attraction for Fatio to taking the potion itself and that being enormously toxic, but none of these have really gained a lot of traction. For my money, it's none of these and maybe all of them. I tend to reject the mercury poisoning hypothesis, as by this time, Newton's level of exposure is actually a good bit lower than would have been the case in the 1670s and early 1680s due to his increased travel schedule. While it may account for some of the paranoia, it seems to be at most a minor factor in what took place. Instead, I think that Newton is really under an enormous mental and emotional strain created by the two mental pictures of himself he's having to try and accommodate. On the one hand, he is the hermetic philosopher seeking out the deepest secrets of nature in solitude. He's working himself harder and harder to try and understand any number of difficult phenomena that defied easy explanation, things like lunar theory and something known as frustrated total internal reflection. On the other, he's an increasingly important public figure who is caught up in a larger and increasingly complex network of relationships and issues. The ongoing churn of public life must have buffeted his mental and emotional sensitivity, and so he'd try and retreat back to his chambers at Cambridge. Soon, however, another thing would pull him back out once again to engage him in some matter or another. As the attractions and opportunities of London pulled him in one way, the semi-monastic life at Cambridge pulled him another. And therefore, the business with Fatio and the business scheme that came with that may well have been the proverbial straw. Into this tension, stretching him to the limit, came the breakup of that relationship with Fatio, something that would have wounded him very, very deeply. Now, Newton's remedy for emotional turmoil had always been to bury himself in work. And this time, as he pushed himself more feverishly into the many projects he had set for himself, there were now even more demands on his time. The entirety of all sent him into an emotional spiral that seems to have lasted at least 6 months. Fortunately, Newton's friends, especially Pepys and Locke, were able to look past the accusations and insults with a remarkable level of restraint and grace. They likely knew that the man that they were dealing with marched to his own rhythm, and so they were willing to make allowances, especially if the rumors of the severity of his breakdown were true. Furthermore, the lifelong tenure granted him by his position at Cambridge gave him the space he needed to recover in his own time. As Newton began to regain some of his equilibrium in the fall of 1694, he once again picked up what he knew, his work on the Principia. What he really wanted to do was create a new explanation or theory of lunar motion based on his assertion that the orbit of the body was influenced by the gravitational attraction of both the Earth and the Sun. While he couldn't have known it at the time, he was embarking on a quest to solve an unsolvable problem, something now known as the three-body problem. So, to get a better handle on what the actual motions of the moon were, something he needed, he knew, like Kepler had with Tycho, that he needed better observations. Fortunately, he also knew just the place to get them: John Flamsteed and the Royal Observatory. Now, it should be understood that, a little bit like Tycho, Flamsteed was very protective of his data. While in his case it wasn't so much out of fear of theft, at least at first, but rather an obsessive desire to make sure that they were as precise and accurate as possible, he was still reticent to just hand out his data to anyone. Nevertheless, Newton was able to convince him to sort of share his observations as long as Newton promised not to show them to anyone else, and that he would also share his improved theory with Flamsteed first so as to help the Astronomer Royal make corrections to his observations. Unfortunately, both men, not quite understanding what they had promised, would struggle to make good on their ends of the agreement. Newton couldn't produce the new theory, and Flamsteed couldn't get Newton the observations that were as good as he had sort of promised. The two men ended up pushing each other, straining their partnership, and in desperation, Newton showed the data to Halley and Gregory in hopes that they could help him sort through it. This violation of trust ruptured the relationship between Newton and Flamsteed, and over the course of the next 5 years, what had once been a collegial friendship turned into barely concealed hostility. After Newton was knighted by Queen Anne in 1705, the pious and increasingly bitter Flamsteed would abbreviate his adversary's title and name, Sir Isaac Newton, as SIN, or just plainly Sin. In March of 1696, Newton would also finally make that move to London permanently. The occasion for this was his being offered the post of Warden of the Mint. The appointment was arranged by Newton's colleague and supporter at Trinity, a man by the name of Charles Montague, who understood that Newton's destiny now lay beyond the bucolic setting of the university and among the scientific and intellectual circles of the city. Montague was a high-ranking member of the Treasury and was also president of the Royal Society at this point, and so he was in a position to advance his agenda on multiple fronts. The number one item on the Treasury agenda was dealing with a growing monetary crisis facing Britain during these years. England's ongoing military conflict with France required a certain level of financial support and stability, but given that England's taxation levels were still fairly low, this had always been sort of a precarious thing. Over the years, the various royal administrations had issued money of differing silver purities, and so, when an effort to shore up the value of England's currency by issuing coinage of higher purity had been implemented, it ran into an immediate problem. The older currency, both of lower quality and often significantly degraded by centuries of clipping, the practice of notching small pieces at the edge of the coins out of the coins themselves in order to accumulate enough precious metal to make new counterfeit coins, did what Copernicus had predicted it would do some 150 years earlier. It drove out the newer, better money. If you recall, the law there in economics was that bad money drives out good. The new money was often melted down, and either the metal was sold or was traded in other countries such as France, or the metal was mixed with the various clippings of the older coinage to make counterfeit coins as had been the case earlier. Montague looked for someone who could offer and implement good, concrete solutions to the problem, and he settled on Newton as the man for the job. The fact that Newton's niece had also caught his eye, I'm sure, had nothing to do with it. To be accurate, what was probably expected is that Newton would offer a few suggestions, maybe form some sort of a blue ribbon panel and get a few recommendations, and then settle into the life of a typical state-level bureaucrat that collected a stipend and then did what he pleased in London with his newly acquired leisure time. Newton, though, as you might expect, was having none of that. When he received his appointment, he took the job very seriously, as he seems to have understood that not only were issues of national security involved, but that if people couldn't trust the money, much of the foundation of the emerging national economy of England would be seriously undermined. As such, he set to work with the same ferocity and single-mindedness that he had brought to his other pursuits. Pursuits that, by the way, continued as he moved to London. His first step was to bridge the immediate short-term crisis by having the Bank of England, newly created, issue paper money to serve as intermediary notes in a barter economy. Second, he worked to get people to scale back on foreign purchases that sent badly needed currency out of the country. Finally, and most ambitiously, he undertook a full recoinage project that pulled every bit of old money out of circulation and then had the mint issue new, more standardized coins with a variety of anti-counterfeiting measures such as edging, where the coin is given a uniform set of grooves around the edge in order to discourage clipping. Here in the United States, and I know not everybody who listens to this is from the States here, but here in the United States, that sort of thing is seen on the edges of the dime and the quarter. And the other thing he did is he created well-defined images on the coin that made them easy to distinguish from poor copies. To do this, Newton bought and installed new state-of-the-art rolling presses and mills that were guarded with the same level of secrecy that usually accompanied, matters of state diplomacy and warfare. The point here was to get new money out as quickly as possible, and so to do this, he established a number of temporary mints outside of London itself. Once he had standardized the money, he went after the clippers and counterfeiters that had eluded all previous attempts to stop their activity. With a sense of moral purity derived from his Puritan background, Newton pursued these culprits with the same intensity of hatred that he had mustered for those he felt had corrupted Scripture. The story of his pursuit of one such counterfeiter, William Caroliner, is the stuff of high espionage and has become the subject of a recent popular book. By and large, his efforts were successful on all fronts, though the recoinage effort took so long that hard money, as it came to be known, was in short supply for quite some time. As a result, he more or less took over the running of the mint by 1698 and was officially made its master in 1699. Among his added responsibilities was to ensure the purity of the metals used in the coinage, something that was tested in the so-called trial of the Picts. Failure in this trial could have cost Newton his freedom, but the knowledge acquired through his work in alchemy proved very beneficial, as he was able to conduct his own proofing tests on various ingots before the trial in order to assure that what was being used to make the coin of the realm was of sufficiently high quality. By and large, I think that it can be said that while only a part of a larger set of policies, Newton's work at the Mint went a long ways towards saving England's currency from becoming worthless, thus allowing England to maintain its position on the world stage through the tumultuous years of the 18th century, where the shifting alliances often relied on a trust that a nation's partners could uphold their end of any financial obligations. Now, as Newton settled into life in London, his work at the Mint did not consume all of his energies. He continued to work on the revisions to the Principia, as we have previously mentioned, though his conflict with Flamsteed and his inability to solve the three-body problem hampered his efforts there. In 1701, he was once again elected as a Minister of Parliament, where he again served without specific note, but likely influenced affairs from behind the scenes. In 1703, Robert Hooke died, and with his rival finally now completely out of the picture, Newton allowed himself to be elected as President of the Royal Society, something that once again spurred an interest in engaging with others in the pursuit of natural philosophy. As had been the case in Cambridge, Newton had spent much of his time up to this point in alchemy and theology, but now that Hooke was no longer around to play the gadfly, Newton decided to return to his work in optics. He quickly pulled together the various notes he had made in the years leading up to his breakdown and had them published under the title of just Opticks. The work was a scaled-back version of his original plan, but it did summarize all of his researches and theoretical ideas dating all the way back to the early 1670s. In addition, he included the De Quadratura and a bit of other mathematical material as an appendix to the work. Unlike the Principia, this was a contribution to scientific knowledge that was accessible to almost anyone working in natural philosophy. The reasons for this are many. First, it was initially published in English rather than Latin, though a Latin edition would follow later. Second, in the way it approached the material, building on experimental evidence rather than beginning with mathematics as the Principia had, it was and still is heralded as the most complete fulfillment of Francis Bacon's ideas of how science ought to be done. Third, at the end of the work, Newton included a list of queries, originally 16, but that number would change from edition to edition, that set out a full and rich research program for other natural philosophers to consider and follow. One of the things that is interesting in these is that he abandons the idea of an ether as being necessary for light propagation, a move very reminiscent of his abandonment of Descartes' vortices in the years before the work in the Principia. He was also fairly explicit in making a macro to micro connection regarding attractive and repulsive forces, a connection he encouraged others to explore. It is likely that this had a good deal of influence when Auguste Coulomb went looking to examine the forces between pieces of electrically charged matter and came up with a description and mathematical formalism that mirrored Newton's exposition on gravity. The Latin edition, as well as the English second edition, would add a number of queries devoted to the connection between natural philosophy and theology. In these, Newton spoke to how he saw God being connected to his creation, suggesting that all of the empty space could be thought of as something like the sensorium of God, and that God was aware of all things going on in the creation in much the same way that human beings are aware of what was taking place in their own brains. In these, it is clear that Newton tied his framework of an absolute space and time to a permanent and unchanging nature of God. It was material, however, that veered towards the heresy of what's known as pantheism in some ways. And so in later editions, Newton went to great lengths to clarify his ideas so that it was unmistakable what he meant. It is, however, completely clear here that both his work on alchemy and theology were profoundly influential in his understanding the enterprise of doing natural science. The former is clearly evidenced in his seeing the occult forces of attraction and repulsion between various materials and the different alchemical processes used to create things like the Philosopher's Stone as applying across all phenomenon, while the latter can be understood through Newton's belief that all of the creation was an expression of God's supremely harmonious nature. As Newton became a leader in the scientific community, not just of England, but also kind of around Europe, he was drawn into two ongoing conflicts. The first was one we've already spent some time on. That is, his sort of debate, conflict, whatever, that was growing with Flamsteed. This came to a head when Newton presented the Astronomer Royal with a copy of Opticks in 1704. Flamsteed, bitter and angry over Newton's success he wasn't convinced was completely deserved, had his assistant present a series of lectures over the book indicating the various quote-unquote mistakes contained in it. With this, Newton seems to have had enough of Flamsteed's interference and pretty much hatched a plot to try to pry the treasure trove of data the Astronomer Royal was hoarding from his grasp. As we have mentioned in a previous episode, Flamsteed was obsessive over the quality of his data. He wasn't going to publish anything until he had checked and rechecked and then double rechecked it. Moreover, there seems to have been a hardening sense in Flamsteed that those who would receive and use the data would have to be quote-unquote worthy in some rather ill-defined way. While the men of the British Navy were certainly worthy, it was not clear that Flamsteed felt that the other astronomers and natural philosophers in London were, especially Newton and Halley. On the other side of this was a growing feeling that the data didn't have to be as perfect and as precise as Flamsteed wanted it to be for the sailors to make good use of it. Flamsteed's insistence on the best possible measurements was delaying a catalog he had been hired to produce and had failed to get into the hands of those who needed it the most. Thus, in 1704, spurred on by the insult, Newton began to work his contacts in the royal family, most notably Prince George, to get them to support the publication of the Astronomer Royale's data. While this might look like Newton was working to get more resources to Flamsteed in the astronomer's ongoing project, what he was really trying to do was force Flamsteed's hand. In this, he was given permission to establish a group of experts or referees to oversee the work, something Flamsteed instantly represented and saw as an attempt by Newton to take credit for his work. In 1706, Flamsteed was indeed forced to hand over parts of the catalog he had finished under seal. In 1708, he then provided the committee all of his catalog data up to 1705 along with lunar observations. After this, at least for a little while, Newton seems to have left him alone more or less, but Flamsteed was still bitterly complaining about Newton in his correspondence with others. This sort of thing then seems to have further aggravated Newton, who used his contacts with the crown to have a letter sent to Flamsteed by Queen Anne herself, telling Flamsteed that the observatory was now under the supervision of a board of visitors to be overseen by the president of the Royal Society, who was, of course, Newton. As a part of this, Flamsteed was to provide a yearly report of his observations in order to improve navigation. In other words, every year he had to turn over all his data. Newton then went ahead and unsealed the data Flamsteed had provided back in 1706 and used it to publish a set of celestial charts without Flamsteed's input in 1711, with Halley now directing that project. As a result, Flamsteed decided to publish his own catalog from the observations, in part due to having to correct various errors produced in Halley's edition. This whole thing finally completely boiled over when Newton, in 1711, offered to improve or fix the observatory's instruments, implying that they were first state property and secondly, Flamsteed had not in fact done this. As Flamsteed had paid for most of the equipment of the observatory out of his own salary, he protested Newton's charges, correctly stating that they were in fact his instruments, something that would be upheld in a court of law later. This apparently sent Newton completely over the edge. The Society's president proceeded to berate the Astronomer Royale for what he perceived to be his lack of production. The entire episode, however, was more of an embarrassment for Newton, who was seen as having been more than a bit uncouth in his remarks. After the publication of Halley's catalog, Flamsteed would work to gather up and burn as many copies as he could get his hands on. While he would be succeeded by Halley as the Astronomer Royale upon his death, Flamsteed would have the last word, as his widow would complete his observation and publish that posthumous celestial catalog, and that catalog was clearly superior to Halley's own. The other conflict we should spend a little bit of time on was, of course, Newton's priority claim with Leibniz over who had developed calculus. Now, to be honest, I don't really want to spend too much time on this, as it is well beyond the scope of what we're trying to do here. And it involves a good deal of national pride and is still somewhat unresolved by historians of mathematics. And finally, it adds little to our picture of Newton beyond what we already know. What seems to be clear here is that the two men developed their ideas independently. While Newton's approach is more general and deals with the idea of continuous change more adequately, Leibniz was the first to publish his work, and his notation was, without question, far superior and more amenable to extension. In a sense, it was more mathematically pure than Newton's. Newton, of course, was unwilling to acknowledge that Leibniz might have created the work without his input. Leibniz, for his part, was unwilling to acknowledge the correctness of the Principia and tried to offer what he felt was a more accurate description of mechanics. While the two men initially started off on a more or less collegial path, things deteriorated rather predictably, with Newton eventually using his position as president of the Royal Society to appoint a quote-unquote independent review panel to weigh the claims and produce a report. This report, of course, was actually written by Newton himself and unsurprisingly gave him credit for the discovery. The whole episode here shows Newton at his most petty. As a part of this was an argument on the role of God in creation, where the two men resorted to accusations of heresy and infidelity to the true faith. Both accused the other of promoting a mechanical universe in a debate that showed most of the readers of the debate that two of the greatest minds of the 17th and 18th centuries were, in fact, talking past each other from positions so calcified that they couldn't find any sort of common ground. That the two men had almost diametrically opposite personality types, and that the intelligentsia of Europe were enjoying what was a bit of a slap fight, didn't help moderate things much. Perhaps the most important correspondence of the whole affair was between Newton's surrogate, Samuel Clarke, and Leibniz, carried on for the benefit of the Hanoverian Princess Caroline. When Queen Anne had died in 1714, the Hanoverians had claimed the British crown under the Act of Settlement of 1701, and so arrangements were made for Prince George to become King George I. Clarke was the king's chaplain, and so began to instruct the very talented wife of his son, the Prince of Wales, on issues surrounding the theological debate. While Leibniz had long been a member of the Hanoverian court in Germany, Clarke's letters won over the branch of the family in Britain, breaking the mathematician's heart in the year leading up to his death in 1716. Newton was fortunate that he outlived all of his rivals, and so, at least in Britain, was able to craft the narrative long after they were silenced by the grave. Hooke, Flamsteed, and Leibniz would find their stories suppressed by Newton and his supporters, while his reputation began to ascend beyond the stratosphere in his final years. In his last decade, he held sway over the scientific community in England, getting his supporters appointed to various positions as he had done with both Gregory and Halley. He continued to write extensively on theology and history, but his work as a natural philosopher and mathematician was done. In 1726, he published the third edition of the Principia, but it added little to the second. In March of 1627, suffering from gout, he died in his sleep in his home in London. The record of the Royal Society related that there was no meeting that week, as the chair of the president was left vacant by the death of Newton. Such was his reputation and esteem that for the first time in English history, an intellectual, a scientist and mathematician, was given a state funeral and laid to rest in Westminster Abbey. In the church's nave, next to the choir screen, is an exquisitely carved monument with the inscription, quote, "Here is buried Isaac Newton, Knight, who by a strength of mind almost divine, and in mathematical principles peculiarly his own, explored the course and figures of the planets, the paths of comets, the tides of the seas, the dissimilarity in rays of light, and what no other scholar has previously imagined, the properties of the colors thus produced. Diligent, sagacious, and faithful in his expositions of nature, antiquity, and the Holy Scriptures, he vindicated by his philosophy the majesty of God, mighty and good, and expressed the simplicity of the gospel in his manners. Mortals rejoice that there has existed such and so great an ornament of the human race. He was born on 25th December 1642 and died on 20th March 1726. So what are we to make of Isaac Newton and his work? Without question, Newton's Principia is the seminal scientific document of the age. For 200 years, it served as the wellspring of physical inquiry. While others would extend and refine its formalisms, it would remain the touchstone of all work in physics over that time. Moreover, it would ignite the Industrial Revolution in a number of ways too numerous to mention here. Even when the ideas of Newton began to be superseded at the dawn of the 20th century by the work of men like Einstein, Bohr, Heisenberg, and Dirac, it is clear that they saw that what they did not as a replacement of Newton's masterpiece, but as an extension of it. Newton wrote, quote, "Let no one suppose that the mighty work of Newton can really be superseded by this or any other great theory. His great and lucid ideas will retain their unique significance for all time as the foundation of our whole modern conceptual structure in the sphere of natural philosophy," end quote. Nobel Prize-winning physicist and particle theorist Steven Weinberg recently said, quote, "Newton's hope," and here he is quoting Newton from the Principia, quote, "I wish we could derive the rest of the phenomena of nature," end quote, has not been fulfilled. But we are working on it, very much in the Newtonian tradition, the formulation of increasingly comprehensive quantitative laws. From this high viewpoint, all that has happened since 1687 is a gloss on the Principia, end quote. But what about the man himself? Wordsworth, when confronted with the statue of Newton that stands on the grounds of Cambridge, penned the lines, quote, "Newton, with his prism and silent face, the marble index of a mind forever, voyaging through the strange seas of thought, alone," end quote. He is, I think, a distant figure to us now. While we live in a world founded on his ideas, it can be said that he was not a man of them. After his death, those who were his followers gathered up his papers, both in London and in Cambridge, and what they found there both surprised and horrified them. Among the relatively small collection of writings on mathematics and natural philosophy, there were reams of paper devoted to heresy and the now discredited study of alchemy. These were quickly boxed up and suppressed, though Newton's religious views would soon become known. Over the years, these works would be scattered until the economist John Maynard Keynes began to collect them. What he found revolutionized first his, and eventually the scientific and historical community's understanding of the man from Woolsthorpe. Keynes had planned to give a lecture on the commemoration of Newton's 300th birthday in 1942, but the Second World War postponed that until 1946. In that lecture, given in a shadowy, as James Gleick puts it, a shadowy lecture hall in Cambridge University, he made the following comments, quote, "I believe that Newton was different from the conventional picture of him, but I do not believe he was less great. He was less ordinary, more extraordinary than the 19th century cared to make him out. Geniuses are very peculiar. Let no one here suppose that my object today is to lessen by describing Cambridge's greatest son. I am trying rather to see him as his own friends and contemporaries saw him, and they without exception regarded him as one of the greatest of men. In the 18th century and since, Newton came to be thought of as the first and greatest of the modern age of scientists, a rationalist, one who taught us to think on the lines of cold and untinctured reason. I do not see him in this light. I do not think that anyone who has pored over the contents of that box which he packed up when he finally left Cambridge in 1696, and which, though partly dispersed, have come down to us, can see him like that. Newton was not the first of the age of reason. He was the last of the magicians, the last of the Babylonians and Sumerians, the last great mind which looked out on the visible and intellectual world with the same eyes as those who began to build our intellectual inheritance rather less than 10,000 years ago. Isaac Newton, a posthumous child, born with no father on Christmas Day, 1642, was the last wonder child to whom the Magi could do sincere and appropriate homage. End quote. I think Maynard's assessment of Newton is an accurate one. He abhorred algebra and even Leibniz's calculus as a corruption of the one true mathematics, geometry. He searched the known writings of his time for proof that the ancients knew the inverse square law of gravitation, because he could not believe that he or anyone of his time could discover anything new. He saw in the crucibles of his alchemical work the occult forces of attraction and repulsion that would govern the nature of atomic matter, given forth by Democritus in ancient Greece. He was a backwards-looking man, formed intensely by the writings of a civilization that was passing away forever. And yet, in his unfathomable mind, so powerfully focused on seeing and synthesizing the unifying principles of a creation made by a rational, but not Trinitarian, creator, he found the breakthrough that would bring to a close the nearly 200-year-old search for the answer to whether the earth moved. Moreover, in spite of his efforts to deny such a universe, he created the framework for a mechanical and clockwork universe that the philosophes, savants, and deists of the Enlightenment would look to in order to search for rational laws that govern not only the behavior of mechanical and astronomical systems, but of all things in the cosmos. First would come the chemists, with the pneumatists and Lavoisier, and then the geologists. Soon, though, the spirit of a world governed by rational laws would jump to the writings of men engaged in political philosophy, and in time, political practice. The ideas of Newton's Principia can be found in the foundational documents of a new American republic, devoted to rational ideas of governance and human rights, taken in part from the writings of Newton's closest friend, John Locke. When, in the year leading up to the beginning of 2000, any number of publications set forth lists of the most important people of the last millennium, Isaac Newton was universally among the top 5 figures mentioned, very often being the number 1 position. The world we live in today, rational, industrial, and modern, can be traced to the influence of his scientific works. Quite the irony for a man who wrote so much in secret on the occult ideas of alchemy. As we close this episode, let me encourage you to read more deeply on this subject if you are interested. While this series is now approaching some 5 hours long, I've really only dug into Newton's life in just a few areas. There are a number of very good biographies on Newton that I've mentioned in previous episodes that you can pick up, with the one from the Oxford Very Short Introduction series being an excellent introduction, and James Gleick's being the most accessible. There you'll find a great deal more on his work in theology, alchemy, and historical analysis. But do be aware that in the effort, you may find yourself exhausted by this walking bundle of contradictions that Newton is. To turn to matters a little more pedestrian, if you haven't already done so, I would urge you to follow us on our Facebook page. And just so you know, we've posted a couple of really great follow-up pieces to our Trappist Observations episode that we posted just this last week. Also, if you haven't already done so, subscribe to the podcast on whatever service you use to listen. And if you have a few minutes, please leave us a review. Also, I'm trying to make some improvement to the show's sound quality, something I know that we struggle with a bit here on the show. If you've got suggestions or feedback, please feel free to send me a note at cldavies@mac.com. And my sincere thanks to Neville in South Africa for his comments on this matter. Finally, if you're enjoying the background music for the show, check out the other work by the Blue Dot Sessions at sessions.blue. It's great stuff. Next week, we'll consider the question that if Newton is the last magician, then who was the first scientist? Until then, full sails on your journey.